Here's some more stuff to memorize. Law of signs. Yep, starting a new chapter. Okay, law of signs. So when it comes to triangle word problems, right now you know SOHCAHTOA, but that only works for what types of triangles? Right triangles. So what if you have a non-right triangle?
Use the law of signs.
Well, one of the things we can use is law of signs. Law of signs says that the ratio of a side of a triangle to the sine of its opposite angle will be the same for any side angle pair you have in a triangle. So you get these three expressions. There's A over sine A. There's side B over the sine of angle B. There's the side C over the sine of angle C. All three of those will be equal, no matter what, for any given triangle. Make sense?
Yes.
Okay. Let's prove this informally with both your favorite and mine, GeoGebra. I'll come back to that. Don't you worry. So I'm just going to use GeoGebra to make a triangle here. I'm going to label all these angles. Here's angle ABC. Nope. I guess I should call it CBA. Angle CBA. GeoGebra's calling that alpha. How about angle ACB? And how about angle CA? Nope. BAC. Come on, GeoGebra. Work with me. Okay. So now I can type down here in the input bar. I can say I want lowercase a divided by the sine of. Now what is GeoGebra calling this angle right here? That looks like a lowercase delta. Or maybe. I don't know what it's called. All I know is it looks like. Where is it? There it is. Okay. So GeoGebra tells me that ratio is 31.85749. Now let's do side B divided by the sine of. Now side B is. To be honest, I don't know exactly. Yeah, B is across from the 65. That is angle alpha. So if I say what is B divided by the sine of angle alpha, and then hit enter, hey, same number, 31.85749. Then I can say I want side C divided by the sine of angle beta, hit enter, same number, right? So this is A over sine A, this is B over sine B, this is C over sine C. You can see I get the same exact number. Now if I move one of these vertices and hence create a new triangle, will that number change?
Yes.
But won't they all three still be the same number?
Yes.
So no matter where I move this, you can see all three of those ratios are the same number, but that number will change depending on what your triangle looks like. Alright? And if I do some weird, like, where it thinks those angles are huge, it goes negative.
Does this still apply to right triangles?
It will still apply to right triangles. The interesting thing about right triangles is one of these angles, A, B, or C, will be what? 90. What's the sine of 90? 1. So one of these fractions will have a denominator of 1.
So it's just a simple.
Right. The funny thing is, historically, students love law of signs. It's very straightforward. They like it more than SOHCAHTOA. And so I will see students, when given a right triangle word problem, actually use law of signs. And then they get that 3 over sine 90, which is just 3 divided by 1, it's just 3. And it's funny that they do that without noticing, oh, I could just do SOHCAHTOA. So I typically laugh at them a little bit. Give you full credit, but it works. But it's a little bit silly, in my opinion. But it works. Okay? All right. Let's do a quick proof. Let's do a quick proof that A divided by sine A is in fact equal to B divided by sine B. And we will use this picture right here to do it. According to this picture right here, what is the sine of angle A? Okay, think in terms of SOHCAHTOA. Look for some right triangles that have angle A. What is the sine of angle A? Opposite over hypotenuse, that is h over b. Right? See this right triangle right here? And that right triangle right there, sine A is h over b. So therefore, the left side of this equation, A divided by sine angle A, that's going to be A divided by h over b. So that becomes AB over h. Agreed? Okay. Let's do the same thing for sine. Or let's do the same thing for angle B. What is the sine of angle B according to this picture? It's h over a, right? Opposite and hypotenuse of this right triangle. So when we do the right side of this statement, we get b over sine b. That's b divided by h over a, which simplifies down to the same thing, ab over h. How did you memorize the Pythagorean theorem? Equals c squared. What's c? but apparently c is usually the hypotenuse. H stands for height.
Yes.
Yeah, drop it like it's height. Right? Snoop Dogg, he's good mathematician.
Snoop Lion.
Hey,
He was in India. He went to India. For India. My cousin's wife.
when saw Snoop Dogg in
Yeah, they saw Snoop Lion in India.
Hey, listen. Now you could easily prove that A over sine A equals C over sine C by drawing a different height. You could easily prove B over sine B equals C over sine C by drawing a different height. But they all end up equaling each other. Okay? So simple SOHCAHTOA can be used to prove that law of sines does in fact work. Yes, ma'am?
This only works for right triangles. This only works for right triangles.
No. This works for all triangles.
So we took out that height thing.
Right. The height typically isn't going to be there.
Okay.
Because if you notice, the actual rule, the actual sine rule does not involve h at all. Right? There's no h in here.
Yeah.
H is just used to prove it.
Okay.
Okay? We call it law of sines in North America, though I do believe many other places just call it the sine rule. They don't call it law of sines.
Okay.
The sine rule. That's law of cosines. Law of cosines is much bigger and nastier. Okay? Now, what can we use it for?
Right triangle.
Because clearly, in order to use the law of sines to solve a triangle, you pick two of these, right? And when you pick two of these, how many unknowns are there going to be in your mathematical statement? There's going to be four, right? You might have side A, angle A, side B, and angle B. So in order to actually be able to solve the triangle, how many of those do you have to know? 3 of them. So either you know two sides and one of the corresponding angles. Well, the statement has four variables. You would have to know 3 of them in order to solve for. Okay, so either in order to be able to solve a triangle using law of sines, you have to know 2 sides and one of the angles. We call that side-side angle, right?
Yeah.
You learned about that in geometry. That doesn't always work. Or you know two angles and one of the sides. And I'm going to be honest, if you know two angles, don't you know all three? Okay, so I'm just going to say it. If you know all three angles and a side, that's when you use law of sines. Again, you can also use law of sines for side-side angle, but that's what I want to spend the entire day focusing on tomorrow. Because those require a whole lot more analysis than just saying, hey, that's side-side angle, we use law of sines. Okay? Cool. Here's our first example. This is what the book is calling an angle side, or I call these, we know all three angles and a side. There's only one triangle in the world that can have this configuration, and law of sines will find it perfectly. Yeah, I don't quote me, but I think the time of no calculator tests and quizzes is done.
No way.
So we'll get back in the swing of using calculators. Okay?
I have a question.
I have an answer.
Things in the last 2 weeks, are they going to be in the exam, even though they were on?
Yeah, absolutely.
Okay.
Yep.
So are we going to have like for the exam we get these
Okay. Sure.
Sure.
Okay, so it's not at all important to draw this to scale, though it doesn't hurt. It's less confusing. But you absolutely do not need to make an obtuse angle look obtuse. You trust the way a picture is drawn, not at all how it looks. So if I wanted to, I could have called this angle right here 102 and this 28. Why not?
How do you know? Okay, this is just dumb, but how do you know which points are like A? What if I wanted that one to be A?
Do it.
You can do it?
Absolutely.
Perfect.
Do whatever you want.
Cool. Yeah, what if I drew the triangle the opposite way?
No, you can't do that. Yeah, well, who cares?
Try.
Yeah, it doesn't matter. I mean, I purposely labeled this one C so that my picture looks a little bit like it's supposed to. Right? C is 102. That's obtuse. So I drew an obtuse triangle. I labeled this C. You could label this B, this A. It doesn't matter, right? Even though I drew it obtuse, I could have labeled this C over here. The angle that looks obtuse does not have to be labeled obtuse. You know, I could totally draw a triangle that looks like this. Label this angle right here, 178 degrees. Label this angle 1 degree and label this 1 degree. What you're looking at right there is an isosceles triangle where this side and this side are the same. Okay, it doesn't matter how it looks, it matters how it's labeled. This doesn't look like an isosceles triangle. This angle right here does not look obtuse,
You should do that on one of your tests.
but it's drawn that way, so that's how you have to do it.
No?
No, I don't want to be cruel.
No, I wouldn't.
She'd yell at me in the middle of the test. This isn't right. It's
I
late.
want that to happen.
Okay, so let's label what we know. We know this is 102.3 degrees. We know that this is 28.7 degrees. And we know that this side right here is 27.4. In fact, I just noticed I actually drew this triangle different than when I did second period. Second period I did BCA. Doesn't matter. Now, technically those are the only 3 pieces of information about the triangle that we know, but what additional piece of information do we basically...
The other angle.
Yeah, we know the third angle for sure. So if in your calculator you would do 180 minus 102.3 minus 28.7. And you see that this other side is 49 degrees. Shh. I tend to make, whenever you know 2 angles, I tend to make the third angle a known piece of info. I don't really treat it as unknown. It's such a simple thing these days, you should be able to find it immediately without any error. Agreed?
Yes.
Okay. Now the hard stuff. How can I find any of the other sides?
Law of sines.
Yeah. In order to use law of sines, you have to have a side angle pair, which we do. We have B and angle B. So I can use those to find, let's say, side C. C over the sine of 102.3 degrees is going to be equal to 27.4, which is what side?
B.
Over the sine of angle B, so that's the sine of 28.7 degrees. So simple algebra tells me that C is going to be 27.4 times the sine of 102.3 degrees over the sine of 28.7 degrees. So the first thing I got to do is make sure I'm in degrees mode, which I am. And given that we're going to be doing a ton of word problems, you're probably going to be in degrees mode for the next few weeks. And so then I can just type 27.4 sine of 102.3. Make sure you close the parenthesis, divided by sine 28.7. And there you go. No, that's not right. I see my mistake. I forgot a decimal point.
54.
There we go. 55.7. And that is feet. Now, at this point, I'm going to look ahead and say, okay, am I going to use this number at all to finish the problem? Because if so, I want to store this big decimal I see here in my calculator for accuracy purposes. Right? I don't think I'll need to, so I'm not going to store it. So 55.7.
Let's go to the bathroom. Can I go?
Yeah.
Hey, Molly.
Okay. That was strange. Oh, what's going on? Oh, golly.
Ooh, that's
Oh.
No, that's perfect. Okay. Next, we find side A. I've already determined I don't want to use C. I didn't store it. So I'm going to say A divided by the sine of 49 degrees equals 27.4 over the sine of 28.7 degrees. So side A is going to be 27.4 sine of 49 over the sine of 28.7. Okay? Agreed?
Yes.
And my calculator, I've already got most of that typed in already, so I'm just going to say second enter. I really don't want so many people to talk while I'm talking. Even if it is about math. Which I don't think it is. So you should get 43.1. Okay, so there you go. I recommend, just to get even more practice at thinking about this stuff, that you check your answer by actually constructing this triangle in GeoGebra instead of checking your answer in the back. Right? What's that? Yeah, it's free. It works on every computer. Okay, so... Anybody else? Somebody just sneezed loudly and the whole class just kind of freaked out. Shh. So under the lines, line segments, and rays menu, you can find segment with given length from a point. So I can click and say, what was the length of the line segment that was given to us? So I can say 27.4. Boom. Then under the angles menu, I can say angle with given size. So I can say, okay, let's do, what was one of the angles given to us?
102.3.
102.3. Okay. Now I don't know how long that side is, so I'm going to draw a ray. And then, I don't want to see this point because it's nothing. What was the other angle?
49.
27 degrees.
The problem is the 28.7 was across from the 27.4, right? So I could draw that angle here, but not exactly know where to put it. So instead, I'll draw the other angle, which technically was not given to us, but I pretend that it was. And that way I can use it to draw another ray. And so that definitively draws our triangle for us, correct? All I got to do is mark. There's an intersection tool, so I can mark where this ray and this ray intersect. And then I can actually draw our triangle. So we can see the side lengths are 55.7, 43.1. Great. For the handful of people paying attention. Next. Okay, here's a good word problem. Besides the very, very last part of this, how tall is the pole? Besides that, I feel like this question is very well worded. So being able to interpret this and correctly draw the correct triangle is important. There's nothing ambiguous about the wording of it. It's very clearly written, but yes, people will still draw this triangle incorrectly. First thing I would recommend is read the whole thing. A pole tilts toward the sun at an angle of 8 degrees from vertical. So if you were to actually measure the angle between the pole and vertical, that's your 8 degrees. So it's 8 degrees. If I just say I have a pole that makes an angle of 37 degrees with what? The ground? So they're saying that the pole makes an angle of 8 degrees, but not with the ground, because that would be a pole that's like this. It's not a very good pole. It makes an angle of 8 degrees from a vertical. So it's just barely tilted.
Yeah, I already did.
But it's got to be towards the sun. Jared.
Yeah, so what if I do my sun over there?
Automatically 90 degrees to whatever horizon. No. Okay. First thing I would do is draw the sun.
Yeah.
Okay. Here comes the sun. Do 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 do.
Because shadows go forward in the direction of the sun.
Right. Here's the ground. Here's my pole. It's angled towards the sun. So okay. So if you were to draw a vertical line, the angle this pole makes with this vertical line is what?
8 degrees.
8 degrees. So if I were to label down here, this right here is 98, and this right here is 82. Agreed?
Yes.
Which side of the pole, the 98 degree side or the 82 degree side, is the shadow have to be on? It's got to be on the 98 degree side with the way shadows are made, right? Okay. It says makes an angle of 8 degrees from the vertical. Oh, I could have totally drawn the sun on the other half, right?
Sure.
But then your pole's going to be tilted that way. Well, that's really steep. So if this is the ground, your pole's tilted towards the sun. This is your 8 degrees now. This right here is your 98. Now the shadow's going to be over here.
Still the same thing.
It's still the same thing, just with full reversal of it. Your pole has to tilt towards the sun. The shadow has to be on the opposite side of the pole of the sun because that's how shadows are made. Huh?
Tilting towards the sun.
Well, we assume the sun doesn't move.
Oh.
Assume the chicken is a sphere.
Kind of know that it's that.
What?
It's a meme. I'm the only one that knows it. It's too cool for you guys.
I feel like I'm trying to talk.
It's annoying, right? You're trying to talk and make a point.
Everybody's talking.
Be quiet. Okay.
Speak out.
There's a. Hey, you two! Split up. Okay. If there's a pool.
You don't know their names, do you?
No. Rahul, right?
Yeah.
And Child.
John.
Child. Rahul and Child.
Did you say Chad?
Yes, his name is Chaz.
Anyway,
Go on, Patricia.
if there's an 8 right here, is there a rule that the opposite, like on the other side, wouldn't it be 8 where the 82 is, or is that not?
This angle of 8 is with the vertical line. So if there were another vertical line, then yeah.
Oh, okay.
But this vertical is perpendicular, so they become 90 plus 8, 90 minus 8. Does that answer?
Yeah, a little bit.
Okay. So then they tell us that a shadow, here's a shadow. Here, I'll make the shadow in blue. There's our shadow. Okay. And they say that the angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. That's this angle right here. So what you end up with is and it's also what, a 22-foot shadow?
Yep.
So you end up with a triangle that looks like this. It's got a 98-degree obtuse angle, a 43-degree angle here, and then the included side is 22. So it's an angle side angle, 43, 22, 98. And then you can use law of sines to solve for this side right here. Does that make sense?
The tallness.
So this is where I think the problem gets confusing, and they say, how tall is the pole? Are they just talking about what I just labeled as x, which would be the length of the pole?
No.
Or is height defined as...
The height's
Pretty
inside.
sure tallness is defined as the height from a horizontal.
I agree. I would totally overinterpret this problem and read into it that we need to find the vertical height. So find this, drop it like it's height, create the right triangle, and go from there. I don't think that's what they intended, though, so we're just going to leave it like that.
Should have said
Okay,
the length of the pole.
here's what I want to do this week. This is your homework for the entire week. Some of this clearly involves problems we're not going to be learning about until tomorrow. So if it's a side-side angle, and the back of the book says no solution or 2 solutions, we're going to focus on that tomorrow. But I want you to come in Thursday with your homework completely done, and I would love to spend nothing but going over homework all day Thursday. Sure. And then you'll come in Friday to take the weekly quiz over just law of science.
What you call?
There should be a snow day, you're right.
I would not enjoy it.
Why?